Okay, so what is 1 point f of 1.1, negative or positive?
Negative.
Negative.
Negative. Okay. 1.2?
Positive.
Positive.
Okay, so your conclusion would be 1.1 multiplied by f of 1.2 is less than 0. So by intermediate value theorem, there is a root on the interval of 1.1 and 1.2. Okay, so that's number 1. Now number 2. Determine the number of iteration needed. So you have 1.2 minus 1.1 over 2 power n must be less than 0.01. So n is must be bigger than what's the answer? Must be bigger than 3.2. So n must be equals to 4. Okay, so that's number 1 and part 1 and part 2. Erase, eh? So we need 4 iterations. So the first iteration, you have f1.1 less than 0, f of 1.2 greater than 0. So your first iteration would be 1.2 plus 1.1 divided by 2, which is 1.15. And f of 1.15 is positive in 0.073, which is positive. So your second iteration, you would have 1.1 plus 1.15 divided by 2. This is 1.125. F of 1.125 is positive 3, 1. So X, third iteration, also positive. So that's part 3. Sama ke jawapan? Do you have the same as what I have done? Okay, saya
Okay.
tanya seseorang.
Sama.
Sama ya. Okay, then go to part 4 using Newton's method. X naught, you have to take 1.1063. So 5 decimal place, so your working must be 6 decimal place. Teruskan ya, it's not done yet. You need at least one more. Can anybody give the answer for x2?
Satu 1.106351.
1.1.
106.351.
Okay, so 1.106338 minus 1. Okay, kena perlu satu lagi iteration nampaknya ni. You need one more because you want 10 to the power of minus 5, right? Hello, Abe kakak. Kakak Abe. So you need one more iteration. Okay, so go on with the next one, part 5, secant method.
Madam,
Yeah,
yang untuk secant tu ambil 1.1 dengan 1.1063 tu ke?
yes. The last one yang dekat
Nombor
part
3 tu.
2, bisection.
Okay, okay.
So it's 1.1063 and 1.1. 0.0636. We still need to which method? X3 secant. Actually, you can just stop at X2, which is 1.10636 sama lah. Yes, betul, yes. We can accept that because you only want up to 4 decimal place. All right, can we move on? Can we move on? Hello class, are we done?
Yes.
Yes,
No
madam.
ke yes? All right, so that should cover up our topics on root finding. So we'll move on to the next topic, which is interpolation. Now, before that, I would like to also show you that sometimes secant is also given in another form. So kalau jumpa benda tu tak salah ya. So you have secant x2 x1 minus fx1 x1 minus x0 over fx1 minus fx0. Okay, so we have this. But if we do a little bit of manipulation, you have x1, fx1 minus x1 fx0 minus x1 fx1 plus x0 fx0. So it's over fx1 minus fx0. And we can cancel up some of these, which is this. Okay. So if we simplify this, you'll have fx0 x0 minus x1, so fx0 minus fx1, yes, over fx1 minus fx0. So if you see this kind of formula, it's also acceptable. Boleh terima ya. Sebab dia it's just a manipulation of this formula. The basic one is this one. This is how we started, and then we can simplify into do some algebraic manipulation. You would get like this. Oh, sorry, salah. fx1 x1 ini x0 fx1 sini. Sorry, silap. Okay, so that would give you x0 fx1 minus x1 fx0 over fx1 minus fx0. So if you see some other lecturers or your friends using that formula, this one, it's okay. It's still the same thing. It's just a manipulation of the original formula. Okay, so our next topic is interpolation. Okay, it's interpolation. Let's say you are given points. Yeah? You are given points x1, x2, y, x0, y0, x2, y2, xn, yn. So you are given n plus 1 point. This is n plus 1 points. Apa pula kat sini 2, 1. X1, Y1. So you are given n plus 1 number of points. Okay, and then you plot this point. Let's say you just plot it maybe like that, like this. Okay, and then if we join this, maybe you would have something like this. Okay, so this method is called interpolation. Yeah, and then when we do the interpolation, what we need is to find the equation of this line, of this curve. For the reason is we want to find the relationship between each point so that we can predict what happened in between. We cannot predict what happened later, or we cannot predict what happened before, because it's interpolation. So what we usually do is we just join them and then find the equation. Now let me just share something with you here. Okay, nampak tak Excel sheet? See, this is X and this is Y. Let me just, you nampak tak Excel sheet? Okay. Tak nampak, alright. Now nampak?
Tak nampak.
Tak nampak.
Tak nampak.
Huh?
Okay, baru keluar.
Okay, baru nampak.
Okay, let's say I have, this is just hypothetical value. Saya letak je value ni. Say you have 3.2, 1.8, 7. This is just hypothetical value ya. Saya letak je number ni, bilangan ni. 6.3 value. Okay, and then I take this point and then I plot it. Saya plotkan. Okay. All right, so I have this line from that point. Okay, and then I want to find the formula. Okay, I can use, let's say, this is linear. Kita tengok this line. This is linear. I can have exponential like that, or I can have a polynomial, maybe degree 2, that's degree 2, or I can have degree 3, degree 4, degree 5, degree 6, whatever I need. But usually people do not go more than degree 2. So let's say power, boleh. Okay, exponential, boleh. Linear, you see you have this linear. All right, now I want to find the equation of the line joining this. Let me just take quadratic. Okay, set intercept display. Okay. So you see you have a formula there given. 1.2778 x squared plus 0.5542x. So that is equation of the line that we interpolated. Kita tak tahu. You see, when you take exact data from the real world, it's not going to fit very nicely in your mathematical theoretical graph. Tak mungkin. So you have 0. R squared here tells you the fit, the degree of fit. If it fit perfectly, it will be R equals to 1. Let me just show you. If I want it to be, let's say now, exponential. Okay, so you see, exponential, you have 0.9705 for R squared. And for the quadratic equation, you have 0.9617. So exponential is a better fit. Fit maksudnya lebih padan lah. Okay, so that is an example of interpolation. Okay, so we have this graph, for example. Then you have this one. And then what we did just now was to find this equation. Okay, usually people would use either polynomial or exponential. Polynomial including linear. Okay, kalau awak tengok laporan, you see, if you see reports on like especially those that deals with money, kan dia selalu garis lurus-lurus je macam ni kan. Actually dia linearize kan. It's not actually nice and perfect straight line, but they use this method to linearize. Okay, so let me just okay, you are given the point. For example, kalau awak pergi, you know those people, they pergi ambil they suka, they measure the rain like every day, kan? If they measure the rain, for example, the amount of rain, and then you have maybe for 1 month, you have 1 to every day sampailah 30. So maybe kat sini you have a volume. It's not volume, it's actually just the height. Maybe 10 centimeter, 12 centimeter, and maybe here 11. So you know this rain in Malaysia, dia tak adalah naik turun macam ni. Because kita macam lebih kurang je every few months pun. So maybe if this is, let's say, your rain, this is your days, and then you have rain maybe like this. Okay, because that's how. Kalau ambil kawasan Cameron Highland, straight je. It's rain. Okay, but like I say, if it's concerned with nature, it's very impossible for you to get a nice graph, because the graph would just goes here and there. Okay, so if you have all these points, we can plot. Tadi saya dah tunjukkan. We can plot the points on the graph. And find some kind of function. Okay, so we can find and find some function that represent the points. And of course, those points cannot is not exactly this apa itu, what's the word? I'm lost for word. The plotted point would not fit perfectly. I'll show you. Salin dulu ya. Okay, so for example, you wouldn't have a graph that fit perfectly. That is impossible because in real life, even though you have, you can say that you have a one-to-one mapping. So you map, let's say, the days and number of rain, but you have to remember the volume of rain. But you have to remember sometimes we cannot go exactly at the same time, or sometime when you want to go on the 12th, let's say, then something happened, you cannot go and watch and take the reading at on the 12th, so that things happen. So for example, let's say if you have points, and then let's say like this, 1 2 3 4 5, and you want it to be linear. Let's say you want it to be linear. You cannot have every point touching a linear, touching the linear curve. So maybe you want it to be linear, but it's like that. Oops. Yang tu je. Okay, so this is, let's say for example. So you see, you have a difference here. Here also you have a difference. And over here also you have a difference. Here also a little bit. So this is the exact point. So let's say this is x1, x2, x3, x4, x5. But the difference of the reading here, this is the difference, is what you call the error. Okay. X exact minus X approximate. Okay, this is the error. There must be error. Tak mungkin tak ada error, because when you talk about nature, it's not a very conforming. It's not conforming to the one that we want. So although it looks, let's say you have a points, and then it looks like it's linear, but it's not going to be exactly linear. You would always have all these outliers. Dia mesti nak keluar-keluar, ada juga. Tak mungkin kita ada graph yang cantik, je straight macam ni. Tak mungkin. It's not impossible if it's exact value. In fact, even those things that you do in the lab also sometimes it doesn't conform to the graph that you want. So this is called error. All right. So there are many ways of doing this interpolation, but we are going to look only at three methods, which is the Lagrange, the Newtons, and the least square error. All right. So we're going to look into these three methods. So why do we interpolate? Okay, one is to find the relation. Yeah. Among the points. Okay, why do we need this? All right, so the reason yang orang heboh is about face recognition kan. Okay, bila dia buat face recognition, dia hanya ambil 12 point dekat muka kita? Kan? Tahu tak macam mana cara kamera buat face recognition? Dia hanya ambil about 12 point or 10 point dalam muka kita. Lepas tu yang the other point yang dia tak kira tu is dia akan interpolate. You know, they take 10 points or 8 points on your face, then they will interpolate the rest. And they do it, the system in the program involved do it very, very fast. Then they terus dapat the shape of the face. That's how one of the ways that they do it using interpolation. Okay, that is why orang adik-beradik bila dia buat interpolation mesti nampak lebih kurang. Okay. So dia buat recognition macam Facebook ke apa ke, like me and my sister, kalau tengok muka kami memang tak sama. Tapi at the 8 point yang dia kira tu mungkin sama. So that's why bila anything my sister buat, dia akan tag me also. Because the system recognize us as the same face. Sebab dia bukannya ambil satu muka. Dia ambil certain points saja. Okay, so that's one reason why we do interpolate. Okay, secondly, to predict or approximate points that we don't have. Okay, what does this mean? Let's say if you have you want your 1 month data. Okay, you have 1 month data. So 1 to 30. And then you have missing 2 days. Let's say you have missing on the 5th, on the 10th, kat sini tak ada. You don't have this. Okay, and then you also miss maybe on the 27th. You miss this point, okay, miss data. That doesn't mean that you cannot do anything with the data. Nanti bila bos awak kata analyze, and then you say we cannot analyze because we don't have all the data. Awak jawab macam tu memang kenalah, nak kena marah lah tu. Okay, when you miss this data ni tak ada, you interpolate. But of course you must report to your audience that this data is not data from outside. It's not the real data. It's data that you interpolate. It's okay. People do that most of the time. So katalah kita ada titik sini data, and then suddenly kat sini tak ada. Kat sini tak ada. Then what they do? They sambung je ni. These 2 point, dia dapatlah, dia predict lah this data. Okay, people do that. So just now I showed you yang dalam Excel, they have the formula kan, like this. Okay, let's say like this. So let's say now I have y equals to 12278x squared plus 0.552x. Now, let's say if I want to find the value for x equals to 2. 278x squared plus 0.554. Okay, so we don't have x for y when x equals to 2. Okay? Sorry, lambat lah pula dia. Okay, so for the example, this one is in the Excel sheet just now. You have the y equals to 1.2278x squared plus 0.5542x. So you want to find what y of 2, then you just substitute 2 there, so 1.2278 times 4 plus 0.5542 times 2, which is 8.019. Now, it's okay if it's not, if it if it's divert a little bit from your points, because this is prediction, this is approximation. So it's possible that it won't be exact. It's okay, it's acceptable, except that you must recognize the error and you must report that this is the method that you use and there might be some error. Tak mengapa. Jangan kata benda yang tak exact, itu bahayalah. Okay, so there's a two most reason that we do interpolation. So one is to find the relation among the points and to predict or approximate points that we do not have in the data. So sometimes you just need to do this. So for this course, we're going to look into 3 methods. One is Lagrange, 2 is Newton's lagi, and 3 is least square approximation. Okay, salin dulu. Okay, so let's look at Lagrange interpolation first. Sebenarnya banyak lagi cara. This is only the three method that is popularly used. There's so many methods that people use to interpolate. Depending on the problem that you need, then maybe people use other methods. So you have Chebyshev and all that. So this interpolation that we look will be polynomial interpolation. Okay, polynomial interpolation. So what is polynomial? Polynomial is given in terms of a naught plus a1x plus a2x squared plus a n x n. However, we usually stops at the quadratic. Only linear, which is p1x a naught plus a1x and quadratic, or degree 2. p2x a naught plus a1x plus a2x squared. Okay, so it doesn't mean that you cannot use others. It's just that this is the common one that people use. All right, so now our task is to find determine a naught, a1, a2, and an. That is what we need to find. Okay, salin dulu. Salin ya. Salin cakap. Okay, so the first one is that we'll be looking is the Lagrange interpolation. Okay, so let's look at linear first. Or p1x a naught plus a1x. Okay, so we need 2 points. Say x naught, y naught, and x1, y1. So the Lagrange method will be p1x L naught y naught plus L2 L1 y1. Okay, where L naught is equals to x minus x1 over x naught minus x1 y naught plus x minus x naught x1 minus x naught y1. Okay, that is a formula for Lagrange linear interpolation. So, for example, okay, let's say you want to approximate y of 1.7 using linear Lagrange. Okay, so you have P1 1.7 x minus x kat sini. X minus, now x naught is 1.5, x1 is 1.8, so 1.8, 1.5 minus 1.8 multiply by 7.6 plus x minus 1.7, 1.5, 1.8 minus 1.5 multiply by 10.3. Which is equals to x minus 1.8 into 7.6 divided by negative 0.3, which is minus 25.3 plus x minus 1.5 10.3 divided by 0.3, which is 34.33. Okay, and we can simplify this as 25.33 plus 9x minus 5.901. So what we want is at 1.7. So you can just write P 1 Okay, so you can have y of 1.7 is the exact. So the approximation is P1.7, which is 9 times 1.7 minus 5.901, which is equals to 9 times 1.7 minus 5.901. So you have 9.399. Okay, so that is your approximation value. So you don't have 1.7, the value for 1.7. So we just approximate that y of 1.7 is 9.399. Okay, shall we stop now? Yeah, we stop now. We'll continue again. Our class will be on Thursday. All right? Hello.
Alright, madam. Dah.
Hi, madam.
Okay, madam.
Kamiko, are you there?
Salah.
Tak jawab.
Madam.
Tak jawab. Ha? Muhammad Emir ada tak situ?
Ada, madam.
Ada. Okay, we stop for now. We'll continue on Thursday. Assalamualaikum. Good morning. Have a nice day. Be safe. Don't be naughty.
Madam.
Waalaikumsalam.
Madam.
Thank you, madam. Okay, madam.
Selamat puasa.
Ya, madam.
Puasa, madam.
Assalamualaikum, madam.
Bye.